Our universe is vast and mysterious. We've made incredible strides in understanding it. Yet some mysteries perplex us. One such enigma is dark matter. It's an invisible substance dominating the universe. It doesn't emit, absorb, or reflect light. This makes it hard to detect. We know it exists due to its gravitational effects. It holds galaxies together. Despite its invisibility, it makes up 85% of the universe's matter. The matter we see is just a tiny fraction. Dark matter is fundamentally different from the matter we know. It doesn't interact with light or electromagnetic radiation. This means we can't see it directly. Scientists are hard at work trying to understand it. Unraveling dark matter is crucial to understanding the universe. It reminds us of the vastness of the unknown. It beckons us to explore further. The quest to comprehend dark matter is a thrilling journey into the cosmos. In the 1970s, astronomer Vera Rubin made a groundbreaking discovery. She was studying the rotation of spiral galaxies. She expected stars farther from the galactic center to orbit slower. But the stars on the outskirts were moving much faster than predicted. This challenged our understanding of gravity. There had to be some invisible matter providing the extra gravitational pull. This was compelling evidence for dark matter. Her research earned her numerous accolades. Rubin's legacy continues to inspire scientists today. Galaxies are not static islands in space. They are in constant motion, engaged in a graceful cosmic dance. Sometimes their paths intersect, resulting in spectacular collisions. These collisions unfold over millions of years. The Milky Way is on a collision course with Andromeda. When these giants collide, it will be breathtaking. Collisions can trigger bursts of star formation. They also alter galaxy shapes, creating new structures. It's a reminder of the constant change in our universe. Galaxy collisions provide a unique opportunity to study dark matter. Remember, dark matter doesn't interact with light. This means it passes through other matter without colliding. This makes it difficult to observe directly. However, during galaxy collisions, we can observe the effects of dark matter on visible matter. By studying how galaxies move and interact during these collisions, we can infer the distribution and properties of dark matter. This is like studying the wake of a boat to learn about the unseen currents in the water. These cosmic smash-ups offer a rare glimpse into the otherwise hidden realm of dark matter. They allow us to probe its behavior and its influence on the evolution of galaxies. Each collision provides valuable data that helps us refine our understanding of this elusive substance. The study of galaxy collisions is a key strategy in our quest to unravel the mysteries of dark matter. Section 5. The Bullet Cluster, Dark Matter's Elusive Dance. One of the most compelling pieces of evidence for dark matter comes from the Bullet Cluster. This is a pair of colliding galaxy clusters. Observations of the Bullet Cluster show a clear separation between the hot gas and the gravitational lensing. Gravitational lensing is the bending of light around massive objects. The hot gas, which makes up most of the visible matter, is slowed down during the collision. This is due to interactions between the gas clouds. However, the gravitational lensing data indicates that a large amount of invisible mass has passed through the collision undisturbed. This separation between visible matter and gravitational lensing is exactly what we would expect if dark matter exists. It's one of the strongest pieces of evidence we have that dark matter is a real phenomenon. The Bullet Cluster provides a unique natural laboratory for studying the properties of dark matter. It serves as a cosmic magnifying glass, allowing us to probe the invisible universe. Section 6. Challenging the known, dark matter's surprising speed. Recent studies of galaxy collisions have thrown up another surprise. They suggest that dark matter might be moving faster than previously thought. This unexpected speed has significant implications for our understanding of how dark matter interacts with itself. The prevailing theory is that dark matter particles interact very weakly, if at all, except through gravity. However, these new observations suggest that there might be other forces at play that we don't yet understand. These forces could be responsible for accelerating dark matter to these surprising speeds. This discovery has the potential to revolutionize our understanding of dark matter. It opens up the possibility of new physics beyond the standard model. This is our current best description of the fundamental particles and forces in the universe. The surprising speed of dark matter challenges our assumptions and pushes us to explore new theoretical territories. This is an exciting time for dark matter research. Section 7. Beyond the Visible. Implications for cosmology and physics. The study of dark matter has far-reaching implications. It's not just about understanding an invisible substance. It's about unraveling the fundamental laws of physics and the evolution of the universe. Dark matter plays a crucial role in the formation of galaxies and the large-scale structure of the universe. It provides the gravitational scaffolding upon which galaxies are built. Without dark matter, galaxies as we know them wouldn't exist. Understanding dark matter could also lead to breakthroughs in our understanding of gravity. The behavior of dark matter suggests that our current theory of gravity, Einstein's general relativity, might need some modifications on cosmic scales. The quest to understand dark matter is a journey into the heart of our universe's greatest mysteries. It's a journey that promises to transform our understanding of physics and cosmology. Section 8. Echoes of the Big Bang. Unraveling the Early Universe. The study of dark matter is intrinsically linked to the Big Bang theory. This is our best explanation for the origin of the universe. The Big Bang theory predicts that dark matter was created in the very early universe. By studying dark matter today, we are essentially looking back in time to the universe's infancy. The properties of dark matter, its abundance and its distribution, can tell us a lot about the conditions in the early universe. For example, the fact that dark matter makes up a large fraction of the universe's matter suggests that the early universe was very different from the universe we see today. It hints at a time when exotic particles and forces, which we are only beginning to understand, were prevalent. The study of dark matter offers a unique window into the early universe, allowing us to piece together the story of our cosmic origins. It's a journey back to the very beginning of time itself. Section 9. The Quest for Dark Matter. A Technological Frontier. The search for dark matter is one of the most challenging and exciting frontiers in modern physics. It requires cutting-edge technology and innovative experimental techniques. Scientists around the world are collaborating on experiments to detect dark matter particles directly. These experiments are often located deep underground to shield them from cosmic rays and other sources of background noise. They are using a variety of approaches, from searching for tiny flashes of light produced when dark matter particles interact with ordinary matter, to looking for evidence of dark matter annihilation in space. The quest for dark matter is driving technological innovation. It's leading to the development of new detectors, new analysis techniques, and new ways of probing the universe around us. The pursuit of dark matter is not just an intellectual pursuit, it's also a technological one, pushing the boundaries of what's possible. It's a testament to human ingenuity and our insatiable curiosity about the universe. Section 10. Our place in the cosmos. Redefining our understanding. The study of dark matter is a humbling reminder of how much we still don't know about the universe. It challenges our assumptions, expands our horizons, and forces us to rethink our place in the cosmos. We are living in an extraordinary time. We are on the cusp of making groundbreaking discoveries that could revolutionize our understanding of the universe and our place within it. The quest to understand dark matter is a journey of discovery, a journey that is sure to hold many surprises along the way. As we continue to explore the cosmos and unravel its mysteries, we are reminded of the interconnectedness of all things. We are part of something much greater than ourselves, a universe brimming with wonder and possibility. The study of dark matter is not just about understanding an invisible substance, it's about understanding ourselves and our place in the grand scheme of the cosmos. It's a journey that promises to illuminate not just the universe around us, but also the human spirit that seeks to comprehend it.